Sorry if you're listening at home. Is there somebody else here? Yeah, Leah. Huh. Hi, Leah. Sorry if you I got to hit record. So if you're listening to this, catch up. Here's the first slide. And that's what we're doing. We're figuring out the shape of a sine graph. And here's the second slide. All right? I'm going to go rogue for 1 second and talk about shape. So positive sign is center line up through a wave. What does negative sign look like? Center line down. What about positive cosine? Let's call it peak to peak or max to max if you like. And what about negative cosine? Instead of going max to max, it goes min to min. All right? Okay. Let's take a mustache. All right, now then. Am I in the right place? Here's where things get a little more tricky because we're going to do everything at once. We're going to talk about the base graph and then how it can be stretched and shifted and horizontally and vertically. It's going to be great. You're going to love it. All right, so first of all, is there a problem to do? What the heck? Is there an actual problem? Why don't I have those? Okay. So I need that equation. Is that correct here? So okay, so let's talk about how do we graph this baby when it's all heck breaking loose. All right, so first of all, the whole idea is that it must be in factored form. And so if this part inside the sign is not factored, that'll be the first thing you do. In this case, do you agree that factoring is not necessary? It's already factored per se. You with me? All right. Now let's talk about what a normal wavelength would look like. Wouldn't it a positive cosine curve look like this normally? Yeah. Actually, I don't know. Why would I put it there? That's dumb. Let's put it down here. Okay. The normal here is 0 to 2 pi. Do you agree? All right. Now, Ms. Ken and I kind of agreed on this. We came to a consensus on this is how we want things done. Right. So in terms of the start, normally it would be at 0. But in here, sometimes in the equation, it gets shifted. Is this being shifted horizontally? What does that? Which part of the equation does that? The pi over 4. All right, so would you please put here, this is a horizontal shift. Is that right pi over 4 or left pi over 4? Right pi over 4. So instead of being at 0, this is now going to be at pi over 4, yeah? This is my starting point. The period. How do you find the period of an equation here? Now, period would mean that instead of a normal wave of 2 pi, it's happening quicker or slower. And so it's a horizontal stretch or squish. You stretch or squish by both. And if it's horizontal, it must be with the x. So which of these changes the coefficient, or the period? This causes it to change the period. In this case, then, the period, here let me give you a little bit of a formula. The period is the normal 2 pi divided by whatever the coefficient is. What's the coefficient in this case? Okay, now I'm talking the coefficient inside the trig function with the x. And so the trig function coefficient is 1. Okay? So in other words, there is no change to the period. It's normally 2 pi, and this isn't being stretched or squished. It's a normal 1. You with me? Are you with me? Okay. Now, when we talk about the normal period here, I'm not a big fan of this here. We said the period is 2 pi. What's half a period? If a period is 2 pi, then what's a half period? Pi. And what's a quarter period? Pi over 2. So do you agree that we're going to talk pi over 2's, pi, 3 pi over 2, 4 pi over 2, or 2 pi before shifting? All right. Now, normally then, we would end at 2 pi, but it's being shifted pi over 4. So will it end at 2 pi anymore, or will that end point be changed ever? Okay, will it be shifted right pi over 4 or left pi over 4? Oh, that's lovely. Okay, right pi over 4, yeah? Well, that's what they're saying here. Determine the stop by saying what did it start at, and then what was the period? It started at pi over 4. It went a full 2 pi in terms of a period. And so where does it end in radian terms? Or in fraction form? 9 pi over 4, yeah? Are you tracking? So in terms of scale, trying to do this well, we're going to trying to follow this. I should have gone by the book. Okay. So in terms of scale, we want to divide the period by 4 to determine the scale. We want to go by, what's the, yeah, I'll just follow it. All right. So let's go by the book. It's this again. We're trying to reach a consensus here. This is not exactly how I do it, but it's all good. If I divide the period to determine the scale, what's the period divided by 4? What's the period? 2 pi divided by 4 is pi over 2. All right, so that's what got me these points. I guess we've already done this. And then we shifted everything by pi over 4 to find the 5 essential points. So in other words, if I I'm going to go rogue for a second here. Do you agree that we said the starting point is pi over 4 and the stopping point is 9 pi over 4? What kind of scale would be logical then to use so we can locate 1 pi over 4 and 9 pi over 4? What should we go by? If I go by pi over 2's, will I be able to find pi over 4? No. So what should I use? Pi over 4. So I'm going to use a pi over 4 scale. 2 pi over 4, 3 pi over 4, 4, 5, 6. I don't know if I gave myself enough room. 4 pi over 4. And we need to go until we get to 9 pi over 4, yay? All right. Now in terms of the vertical scale, let's talk about that. What does the 1 outside do? If you add 1 to the function, what does it do to the graph? Push it up 1. So this is a vertical shift, yeah? Think of it as the center line. It's normally centered at the axis 0, and now it's been vertically shifted. What about A? What does that do? Multiplying stretches or squishes, and it's outside the function, so it's stretching the function. So a vertical stretch or squish, it changes, what do we call that, how high the wave goes? changes the amplitude. All right, so for this problem, how has it been vertically changed? Do I look at the 1 or the 3? The 1. And it's up 1 or down 1? It's up 1. So the center line is 1. And how high does it go above 1 and below 1? 3. So what's the maximum going to be? 4. I did not give myself enough room. And what's the minimum? 1 minus 3, so -2. It'll go to a low of -2, okay? All right, now I know I expect a wave like that because it's positive cosine. And I said the starting point of my wave is where? Pi over 4. So I have a top point at pi over 4. And where's the wave end? 9 pi over 4. Now let's work out the in-between points. What's halfway in between? 5 pi over 4. And where's the graph at 5 pi over 4, the middle? At the minimum, at -2. And what about the quarter points? What's in between those? 3 pi over 4. And that seems like it's 2 boxes away. And then 2 more boxes away is to 5. And 2 boxes past that is 7. So the wave would look something like that. My scale's uneven. You get the idea. All right? Looks like it has a 0 between 3 pi over 4 and 4 pi over 4. We'll figure that out later. All right. Now, that was a bit of a mess. I'm sorry I kind of muddled my way through there. Let's try another one, walking through this together, okay? Number 2. Looking at the steps, what's the first thing I need to do? Factor. It says factor. This is not in standard form. So here you need a factor. What do you need to factor out? The 3. And what do you have then inside the parentheses left? Pi over 3. It's 3. All right. Cool. Let's put a rough draft. Oh, sorry, I guess I put that in the wrong place. 2 sine 3 plus 3. All right. The starting point. What's the starting point? What's the basic? I'm going to do a rough draft over here. Sinusoid positive looks like that, yeah? And normally it starts at 0, but this is shifted. Am I looking at pi over 3 horizontal shift? Is it left pi over 3 or right pi over 3? Left. Okay? So it's going to be shifted left pi over 3. All right, I'm with you. The period. What's the period? Look at that formula up there. It's 2 pi divided by 3. And so the period is 2 pi over 3. Where will it stop then? If it starts at negative pi over 3, it goes 2 pi over 3, then where will it end? That's negative pi over 3 plus 2 pi over 3 away. Pi over 3. If I take negative pi over 3 plus 2 pi over 3, maybe I should write that down. I know you could do that mentally, but in terms of making clear where we're coming from, it's the start plus the period gives you where you'll end. All right. So in terms of the important points, let me do this according to what you wanted me to do. Let's divide the period by 4 to determine the scale. If I divide the scale, the period, divided by 4, then a wave was 2 pi over 3. I divided it in half, that's pi over 3, and half again. Then what is a quarter wave? Pi over 6. So we're going to use a pi over 6 scale. Are you with me? Now then, would you please just put in the x-axis for now? This goes to that note up there. Don't draw the y-axis until you found all the intervals on the x-axis. So we're going to go with, go 0 there and go pi over 6's, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, and so on. Okay, cool? All right. With that, then, now it's pretty easy to put the y-axis in. Where's the y-axis? 0. What are the important points vertically? Where's the center line? It's right. Here's the vertical shift, right? So there's the center line. It's centered around -3. How high and low will it go above that center line? It'll go from 2 up, which puts me at -1, to 2 down, which puts me at -5. You follow me? All right. Now let's go back and locate the starting point. Where do I put the starting point? In terms of pi over 6's, what is negative pi over 3 equal to? Negative 2 pi over 6's. So I want to put the starting point of the wave at negative 2 pi over 6. So that's here. Here's negative 2 pi over 6. Where do I put it? At the max, the center, or the min? The center for sun. So that point, yeah? Now if the scale is pi over 6, that means then that every quarter wave is pi over 6 away, which is to say this next point, to get to the next point from the center line, is just to go 1 pi over 6 over, and I have a max. And then if I go 1 more pi over 6 over, doesn't that take me to the y-axis? And that's back to the center. That's another pi over 6 over. Where does that take me to? The minimum. And another pi over 6 takes me to center. That seems to end the wave at 2 pi over 6. Does that jive with where I said when we would stop? Said we would finish a wave at pi over 3, and isn't that exactly where we're finishing? So you get a wave like that, and you can do more. Certainly you need at least one period, but if you wanted to do more, all you have to do is just go to the next box, put the next point. And so with the scale, shoot, you can do as many points as you want, although one period is required. You follow? Is this the next one, yours? Yes? No? Okay, well, she wrote us a note to do number 16 on the problem set. Is number 16 on the problem set the same as this? Oh, I guess you wouldn't know then, would you? In the interest of time, let's go to the problem set and get some practice on the problem set, shall we? Hi.
Usually what we like to have is we just have to list like 5 pi over 2, like those points on the x-axis.
I wouldn't put pi over 2's if that has nothing to do with periods. Oh, no, that's garbage. No, I would never.
Okay.
Oh, that's garbage. Yeah, I would. No, I would demand a skip. Okay, yeah. So here we go. It says skip number, go to 16. So let's look at 16 and let's walk through 16 together, actually. Okay. Now maybe you should, do you feel good enough to try this on your own or walk through one together? Ah, you sissies. All right. All right. So, what's factor form? You're going to do the more talking now. What's factor form? Take out the 2, which leaves me with y equals negative cosine of? Take a 2 out, and what's left? X minus pi over 8. If you're not sure if you did that right, you can always distribute the 2 back in and say, is it right back to where I started? And the answer in this case would be yes. So I feel like we're good. All right? The starting point. What does a cosine wave normally look like? Peak to peak, center to center, min to min. If it's negative, if it's positive cosine, it's peak to peak. If it's negative cosine, it's min to min, or valley to valley, whatever you want to call it, all right? It normally starts at 0, but how is it being shifted? Okay, 2 vertically, that's true. When I say start, I really want to focus on the horizontal. So where's the starting point horizontal? Pi over 8, okay? The vertical, usually people don't have as much trouble with, so let's focus on the horizontal. Pi over 8. What's the period? Pi. It's 2 pi divided by the coefficient of x that you factored out, and so it's pi. Cool. All right, so if we're starting at pi over 8, we travel pi. Where does that finish me? 9 pi over 8. All right. Now, in terms of the scale, the scale said take the period and divide it by 4. So what is the period divided by 4? Pi over 4. How many pi over 8s is that? 2 pi over 8, yeah? So, in terms of the scale, should we go by, yes, we could do 2 pi over 8s, and that's fine. I'm going to use 2 pi over 8 because that will allow me to figure out where 1 pi over 8 and 9 pi over 8 is. Are you with me? So the scale is 2 pi over 8 and we could continue on 4 pi over 8, 6 pi over 8, 8 pi over 8, 10 pi over 8, so on. All right? Now we're ready for the vertical component. What's the center line? 2. Okay, right there. What's the amplitude? Amplitude is what's in front of the cosine. So -1, so it's going to go 1 up and 1 down. Do you agree? Have to put those in. If you feel like the graph gets too busy putting those in, that's fine. I am in the habit of putting them in. All right, so we said a negative cosine wave looks like this, and our starting point is pi over 8. So what point do we locate first? Where's pi over 8? Isn't that right in here? Okay, and is it at a minimum, center, or max? Minimum. All right. So if we then end at 9 pi over 8, isn't that right here in between 8 and 10? Not crazy about this. All right. So each quarter wave, we're going to go 2 pi over 8, yeah? So when I start here and go 2 pi over 8, doesn't that put me at 3 pi over 8 at the center? And if I then go 2 pi over 8 more, where's that put me at? 5 pi over 8. And then 2 pi over 8 more than that is 7 pi over 8. And finishing at 9 pi over 8, which we have located. So you should have something like that. Yay? I feel like I did too much talking there, darn it. Do we have time for you to do one on your own? Let's do it. Try, which one? 16? Oh, my bad. Which one's the best one to go next? Try 17. And part of this, you're going to have to persevere. If you're thinking, oh, I can't do this, then you don't be such a quitter. You persevere. With practice, you'll get good at it. Just like anything. Say you can, baby. Say you can. Negative 2 pi over 3. So you have okay, so it's the opposite here. It's left 2 pi over 3. Now, this is the problem that I am having with our directions. Okay, the scale of pi over 4 is super, but if I put pi over 4 as a scale, how am I going to find pi over 3? Yes? Okay, so by our directions, which are, I'm starting to think are not great, it's the total period of a wave, which in this case, in this case, the total period is pi. And it's important to us that you can find all these points, and that's half and quarter of a wave. So to answer your question, we typically, to find the scale, we want to definitely take the period and divide it into 4 equal parts to find the max, the center, the min, and back to there. But the problem is that we've got a little difference between the quarter points and the period, the start. And so maybe a better scale would be to choose something that we could use both. So the scale, what kind of factor denominator would be able to find thirds and fourths? 12. Okay, so if you use 12s, use pi over 12, you would be good to go. Okay, sorry. Could have gone better, but we'll do more tomorrow. Have a great day.